Good afternoon, everyone. My name is Sergey Shishkin. I work at Standard Chartered, but this talk is not an experience report of yet another bank undergoing agile transformation and scaling their teams. I want to do something different today. I don't think the world needs yet another scaling model like Spotify, Safe, Less, or anything like that. I think the best people learn is by experiencing context, learning through games, learning through safe experiments, recognizing patterns, and then when they recognize them in real situations, they know how to act because they have some learnings. So this is why I want to present patterns here for you in a more interactive form, in the form of a game. Imagine software development is a product development game. Before we go any further, who in the audience are software engineers? Okay? Who are the managers or team leads or have authority over team structures and anything like that? Okay. Who works in an engineering organization of more than 10 engineers? Okay. I definitely know why you're in this room. I'll now be talking about challenges of distributed teams. So if you want to hear about that, Simon is doing a talk on exactly the same topic, distributed teams, just across the hall. But today I want to present you a possible development scenario of a small engineering team that grows and undergoes different stages of growth. And I think we'll learn some lessons by observing how this particular team behaves in each situation and draw conclusions from that. But before we start, from my personal experience, I've seen teams at different stages of growth, from small to large. And I'm yet to see a team that is large and that doesn't have any issues. Like, the bigger the team gets, the harder things are. So it's like in a fight club. The first rule of scaling is don't scale, right? If you've been to a keynote of Ajay this morning, you've seen this. You have a very, very small team of very efficient, competent engineers with powerful tools, able to juggle gigantic infrastructure. Do you think they would be able to achieve the same if their systems operations team would be 1,000 people big? Right? But it's not unheard of in large multinational corporations to have infrastructure teams that big. I don't think they're as efficient as this small team is. So I think if you only take one thing out of this presentation is avoid scaling at all cost. Because the main thing there is that you can grow a large simple system out of a small simple system. But you cannot grow a complex small system into a large simple system, right? That will never work. Keep to simplicity. So let's meet our protagonist, Mario. So Mario is an engineering manager in an organization. So he has just one developer over there. They, together with a product visionary who is also a single person, work on just a single product. So one application, one engineer, one product owner. Simple. right? The world is beautiful for Mario. There are no challenges. In these humble regions, remember, we have a unified product direction. We have uncomplicated solution. We have fast technical decisions. Whatever the engineer wants to do, we just do. Doesn't have to ask an architect, a technical standards committee, whether or not to use a new Node.js library in the project or not. Everything is fast, everything is smooth. So remember this scale, because our Mushroom Incorporated will never look again like that. It will only get worse after. So, level 1. Obviously, every challenge in this scaling game starts with a growing demand. Otherwise, we would basically continue indefinitely just working as a single engineer, doing what we like for the rest of our days. But for some reason, people want more of our product, and the demand grows. So we need to do more and more and more. There can be like additional stakeholders, investors who want to us to take on additional challenges. So what shall we do? Right? What most organizations do in such a situation is they just start scaling or engineering organizations. So we have now a team. That's the first pattern. It's pretty trivial one, but it has its properties that we need to observe before we go any further. So, for example, there are obvious benefits of having a team rather than a single individual. We have diversity of ideas. People from different backgrounds, from different technical skills can contribute and solve problems faster. We obviously have increased throughput. Not a single person doesn't have to do everything themselves. We can parallelize things. We can do things more efficiently. We also decrease the so-called buzz factor, right? It doesn't have to be that dramatic with the buzz, but like people get sick, their kids get sick, they take vacations, they have emergencies, things like that happen, and we want to have a steady throughput. We don't want our product be out of market just because somebody needs to attend their family life for some reason. But the team also has its cost. So there is a cost of agreement. Everything needs to be agreed now. It's not just like I do things like I want in, say, in JavaScript, and another developer on the same team does rewrites all my code in Java next day, right? It's unproductive. We need to be able to agree on things, and it's a cost. We also have shared resources. So you see this with various branching models. When people want to commit code, they have to be able to integrate the code together. So these shared resources like code repository, deployment environments, databases, things like that get contended over. And it's not just that. We cannot continue scaling this one team indefinitely in size. So what happens in ideally is like we have this linear scaling line, right? Does anybody believe that like this is what happens in reality? Okay, probably I've already given away the answer. But teams don't scale linearly. There are two things that limit the scale. So one is contention over resources. As you know, or might know from distributed computing as well, underutilization, distributed systems, when they have something that they cannot completely independently parallelize, where they have to agree on something, where they have to wait in a queue, that limiting factor limits how much theoretical parallelization can be achieved. And this is a logarithmic limiting factor, so this orange line over here. But it's not just that. The larger the team becomes, the cost of agreement grows exponentially. What it means here is that our throughput is also declining. So in reality, we have more like a purple line. There is a sweet spot over there. And one thing you also notice is that in the beginning, the scaling is slightly more than just linear. So this is the synergetic factor. This is this diversity of ideas. This is where actually having more than one person working on a team is much more beneficial. So we want to stay in this range where we get the benefits of a team, but we don't get the negative factors. Also remember the buzz factor, right? So that's why you want your ideal situation is you want to be like slightly on the right side, so that when people take vacations, you are like right in a perfect spot. So at this stage, when we have just one team, I would say the community in general, engineering community in general, has solved this problem already. There are very well-established solutions. For example, if you look at extreme programming practices, apply every one of them, and you get your team as efficient, as productive as it can be. The most important ones are collective code ownership, code standard, continuous integration, pair programming, and test-driven development. So those factors help mitigate the negative agreement and contention over resources. And here, I'd like to stress this point. I see many teams go past this stage too fast. They don't master the technical excellence practices, and they scale further. So before they learn to walk, they start to run, and they stumble. What it results is a large organization which lacks technical excellence, lacks competence, and it's harder to get this backwards when you have a large organization with its all norms and how things are done and people perceive it is a given. So focus on technical excellence first, and try to stay in a stage of single, efficient team as long as you can. But obviously life is not so easy. So we have next challenges. And one more slightly interesting challenge is when demand grows, we recognize that we don't have just one stakeholder, and the product vision is not that clear anymore, but we recognize that there are multiple forces that pull us in a different direction from the business perspective, from the domain perspective. So how do we overcome this challenge? Well, we can create more teams. Because at this stage, when we've grown our single team, we want to start splitting the teams because it's not efficient anymore to grow the same team bigger and bigger due to the factors that I mentioned before. One of the patterns that I particularly like in such situation when you have more teams is so-called feature teams. Feature teams are distinct teams that work on the same code base, on the same application, on the same solution. But they work on different features. So if we have a single backlog of requirements, both teams pull items whenever they have capacity, implement them on the same code base. And this is why having continuous integration and extreme programming practices is extremely important, because now you have two teams that have to coordinate, and it gets ever more challenging. So the benefits of feature teams are, so you have flexible prioritization for multiple stakeholders. So your stakeholders can work on the backlog and you can prioritize the relative importance for the teams, but the teams are isolated from that ambiguity of that chaos of the external world. So they pull items from the backlog and implement them. You have increased throughput because you now have more teams, but there are also increased cost of coordination because now teams talk obviously to themselves, but between each other they need to agree on how they integrate their code together, and again they get contention over resources. So you can read more of the pattern feature teams at less.org. So less is one of the scaling frameworks. I'm not advocating for using it, I'm just saying that it describes this particular pattern rather nicely. So what happens next? Well, demand grows even further. You probably know that like every other challenge from now on is like it's getting ever bigger and bigger, bigger and bigger. How do we tackle this? Well, at this stage, we can look at how we structure the backlog. For example, we can introduce requirement areas. Requirement areas is another pattern from LESS framework. So requirement area is a subset of the backlog focusing on a particular view of the product. So for example, if you have different stakeholders, imagine our Mushroom Incorporated is building a marketplace for a particular service like Uber or Grab or something like that, where there are consumers, there are service providers. They need to meet together on the same platform. So we can divide our backlog into requirements that face the consumer and requirements that face the service provider. And we can identify product owners for each area, and the teams can work on a particular area and actually get used to that particular domain area more than the other, so that they focus on this. We get customer focus, we get manageable scope of prioritization, so the teams don't have to understand everything about the product, they can focus on their area. Important to note that here still, we don't build components, we build features end to end. So every increment is potentially shippable. That's very important. But what we get is a fragmented product vision, right? That's inevitable. And the cost of agreement grows even further. So as you see, even we have some benefits, the costs grow and grow. So this is why it's important to try to stay at the previous stage as much as possible if you can get away with the demand. So you won't believe what happens next. Even more demand. Okay, now we've grown to a scale where we can start tackling the problem with technology. So we structured our backlog. We have our teams that operate at optimal speed with technical excellence. And we can look into how we structure our architecture in a way that supports our ever-growing complexity of the product. We can introduce distributed architecture. What we get through that is partition domain complexity. So we can have services that are responsible for particular business capability. Again, it's very important to distinguish that we're not separating front-end from back-end from database here. These are business capability services. This is what we want to start separating. Localized technical decisions, because every service now is a separate thing, can be deployed separately, can be developed by a separate team. Testing is localized as well. Of course, we need end-to-end integration testing in addition. This comes as a release coordination and cost of agreement on service interfaces as an additional cost. Also, because it's now a distributed system, it's bound to new types of failures, and that's why it's more difficult. So don't do this unless you know why. Sorry. So here it's important to note the famous Conway's law. Has anybody heard about Conway's law? So in a nutshell, it means that the structure of organization determines the structure of the technical solution this organization builds. Roughly phrased. And what it also means is that if we shape our organizational structure the way we want our architecture to look like, because people are so adaptable, they will amend the solution and they will mold the solution to the structure that they operate in, right? It's counterintuitive, but it's much easier to restructure the teams in the way you want your technical solution to look like architecturally. And the teams will make it happen that the architecture follows that structure. So here is a non-exhaustive configuration of a potential teams and services cuts. So the blue, purple, and red means the UI, the business logic, and the data, roughly, right, if we have the separation. And first we started with a single application, which is just one boundary containing all the three. And there are multiple ways to structure architecture in teams. So for example, we can create a front-end team and a back-end team. I wouldn't advise that. Why? Because we cannot build features end-to-end. We cannot implement the feature teams pattern in this configuration. Far more separating the data from the business logic. So there are like various situations that you can have. Probably a very pathological one is the last one, where everything is separate. Right? Just imagine the cognitive overhead that people will have agreeing on service interfaces, coordinating releases and testing of all this mess. Like, this is enormous. In my personal experience, what works best, although it's very counterintuitive and very few organizations really do this, is the one but last solution at the bottom, where we have domain pillars providing business capabilities end-to-end with the user interface, domain logic, and the data. So this is what real service-oriented architecture is supposed to be, right? Business capabilities and teams focusing on them end-to-end. But this one can work as well, where we have potentially a one service team or many service teams working on business logic and data, and having multiple front-end facing teams that potentially target different user groups, right? That can work as well. Or, for example, like if you have different mobile platforms for your front ends, that can be beneficial as well. So what happens next? Demand grows even further, right? It never stops. And in fact, it's some kind of an entropy. It just grows and grows and grows. And the more people use our products, the more popular they become, hopefully. So it's a good problem to have, but it's a challenging one for the team. What can we do? Well, at this stage, we can try microservices, right? I know microservices is all rage nowadays. Everyone wants them. But just let's compare the cost and benefit. So obviously, we have reduced team contention. So microservices is like service-oriented architecture done right. It's independently releasable units of software and business capabilities. So teams don't contend so much. They have to provide backwards compatible APIs and interfaces. Also, they focus just on a particular business capability that the microservice supports. They don't have to think about the complexity of the whole market and how our product operates. But there are also negative parts. The changes become unpredictable. And in fact, for me, the main difference between a service-oriented architecture and the microservices is that microservices are so fine-grained and independent that you cannot possibly coordinate releases of them, right? Because if you're trying to coordinate them, then what you're doing is not microservices, it's just like overblown and overgrown service-oriented distributed monolith. So operational complexity grows as well. You have to be able to roll back failed attempts of releases. You have to balance canary releases and things like that. It's like really, really complicated. And in fact, Martin Fowler has a great write-up on prerequisites for microservices. It's like, I've seen people dub this article as you have to be that tall to use microservices. So you definitely need to be able to automatically provision your infrastructure. If you have to buy servers, install them, and wire them manually in a data center, then don't do microservices, it will hurt. You need to be able to deploy your services automatically, pressing a button, or even not pressing any buttons at all. You have to have excellent observability, logs, tracing, metrics, all integrated and aggregated. Because when things go wrong, you don't know even why they go wrong. It might be that it's like 3 services far away, something changed, and you need to be able to identify issues like that through metrics and traces. So when you start separating teams into microservices, there are additional patterns that emerge. And I'd like to highlight this model from Simon Wardley, which shows different phases that innovation and ideas come through. So they start on the left with the genesis, where somebody just hacks something together. It's an experiment. It's somewhere in the shed. It's not working without this particular person knowing which buttons to press. But it's something inspiring. It's something that is innovative. Then pioneers or people early adopters who see value in such innovation, they copy this practice and they have custom built solutions around the same practice. Then somebody builds a product out of this and it's now off the shelf. You can buy it, you can rent it. And eventually things become commodity and utility. So when you structure your teams at that scale, you might want to keep this model in mind, because different teams can find themselves at different stages of focus of the innovation they're doing and the work they're doing. Some are more customer-faced, some are more, for example, working on infrastructure, operations, and platform. It doesn't mean that platform is, by necessity, is utility and commodity. Utility and commodity would be your electricity bills, something that you don't even think about. But on the other hand, look, Google at some point was researching how to improve power blocks of their servers to save cost. And it's clearly something custom built for something that others consider commodity. So there can be innovation, but it's far removed from the customer. So some of your teams might be focused on the customer and product development and building innovative features. Some of your teams might be focused on reducing cost and optimizing things and economy of scale. So here we come to a pattern called platform team. So a platform team would be a team that builds components for other teams to use. So this is obviously beneficial if you have, for example, your big data infrastructure. Not every team needs to know how to move big amounts of data. You can have a team that focuses on providing this as a platform for feature teams to build features on. And they can do it really, really good using the economies of scale. So the benefits are solutions are unified. Teams don't have to reinvent the wheel all the time. They can use ready-made solutions. Economy of scale again. You also build competence by nurturing skills that are rare. So for example, people with DevOps or service reliability engineering skills are really, really hard to find. And if your business depends on these particular skills, you can build these centers of excellence and teams that take pride in what they do, providing a platform for feature teams to build upon. But there are also drawbacks. So for example, what I sometimes tend to see is that such platform teams provide solutions that supposed to fit all, but they actually don't. They are mediocre solutions because sometimes such platform teams are so far removed from requirements of the actual development teams that they come up with crazy ideas that nobody actually has a use case for. They also become an innovation bottleneck sometimes. So how to overcome this is using this pattern of looking for bright spots and then promoting them. So looking at feature teams, those innovators and pioneers who build something, solve a particular problem in a rather nice way, and then scaling this, making it more accessible to other teams, making it more efficient. So there are many more patterns of how to structure teams and how to restructure teams, and I highly recommend work by Heidi Helfeld on dynamic reteaming. The book covers really exhaustive set of patterns of how to split teams, how to grow teams, how to join teams. Basically, it's like Martin Fowler's refactoring book, but for organizations. So it's a really indispensable resource here. So now moving forward, what happens when we grow beyond, for example, 25 teams and we have dozens of microservices, but we identify that we have more and more stakeholders, like multinational corporations or even startups that operate in multiple markets have this. Every country's regulatory frameworks are different, like financial reporting is different. All these different aspects of a product that in the early stage you don't even think existed are now becoming ever more present. So you have so many stakeholders that it's not even possible to put them all in the same room and structure your backlog in requirement areas anymore. So how do you deal with this situation? At this stage of complexity, we need emerging solutions. It's not a cookie cutter anymore. It's not just a good or best practice. And the pattern I've seen in the industry applied is what I call developer mesh, as a kind of a service mesh, but for organizations. And it works like this. So imagine we have a network of engineers in our big team. It can be dozens, it can be hundreds. Now people not just work in fixed teams, but they pick problems they are curious about. They pick problems that they feel are important, or they pick problems that somebody else was able to advocate that they are important. And then they team, solve the problem, and then they reteam again. So it's like open source community in a way. Nobody is forced to work on a particular problem. People work with their feet and they self-organize. And this is why this pattern is emerging, right? Because we don't have a structure that tries to predict the complexity of outside world and be perfectly fit for it. It tries to adapt, right? It tries to be so flexible that whatever challenges the outside world throws at us, whatever new stakeholders and views of our product come up, our organization is able to react. So we can have multiple areas and people just like a beehive just roam from one area to another and work on problems together with people they like on the problems they like. So the benefits of such an approach are we have motivating autonomy. People are so excited to work in such organization because every day they can choose their own adventure. Like, isn't it cool to work like that? We have less organizational overhead because we don't have to maintain these fixed structures. It's more like a self-organizing hive. We have organic prioritization. It's not just one product owner now or a team of product owners who decide what has to be done in what order. Is emerging organic prioritization. But also we don't have central product authority. So for some organizations, this can be unthinkable. Example of such a team would be, I think, GitHub several years ago. There was a talk on InfoQ called How GitHub Works No More, or No More Works. So GitHub is a special company, of course, where every developer can very well represent the stakeholder. It's a product by developers for developers, right? So maybe it's a special case, but it's a real case where a company could have a model and could sustain a model at least for a while, where developers pick the problems they're interested in and they just solve it. But you also have to be that tall to operate at this level, right? Prerequisite for this is that the company has to have a clear mission and purpose, so that everybody at every level has to be able to make important prioritization decision on their own. They don't need to ask managers or product owners, should we work on this, should we work on that? That should be obvious for everyone. And this is the main challenge. But in my opinion, this is a worthwhile exploring pattern because at least this structure enables organization to grow organically further and further. and accommodate all the possible challenges of the outside world. So in summary, to summarize what we've just walked through, I'd like to highlight the Cynefin framework by Dave Snowden, which is not a scaling framework, it's a thinking framework, right? It teaches you to think or see the world through one of these few lenses. You identify where your organization is. So we have a few areas here. So we'll start with obvious. So obvious area of a problem domain is when it's like 1 + 1 is 2, it's always 2. We don't have to think about it. There are no multiple opinions about it. There are obvious best practices, just use them. And in our example, extreme programming practices for a single team is the obvious domain of the organizational complexity, right? Just don't think about it. Apply these practices, they work. Hundreds of teams prove they work. Then we have complicated, where we need analytical thinking, where there can be multiple opinions, there can be multiple approaches. One can be better in one situation or another situation. And then there are experts who debate which one works in which situation. These are good practices, but there is no single best practice. This is our feature teams, requirement areas, and distributed architecture. There are good practices how to make scale of that size work, but there is no ubiquitous solution for that, right? In one context, service-oriented architecture might work better. In other contexts, a monolith might work better. Just compare. But you can analyze and come up with a solution. And then there is a complex domain in which you cannot predict what will happen. It's like your microservices or your developer mesh. There is just so huge amount of complexity and different views and priorities that you can only try things, sense what happens, and then react and adapt. So through this lens, we can follow through the journey of our team on the following framework. So at the x-axis, horizontal axis, we have the product complexity or domain complexity, starting with obvious, going through complicated and the complex. And on the vertical axis, we have our technical solution, how that adapts to the problem. Again, starting with the obvious single unit, single entity, going through some distributed but still manageable solution into something organic and emerging like microservices. And note that we have areas like decision paralysis on the right. If we have our simple solution, monolithic solution, and we try to apply it at the level of uncontrolled, complex external world demand, we will face prioritization paralysis. We will not know, the contention will be so high that we will not know what to work on at which particular stage, because we have to somehow serialize all the changes that we make on a single solution. So at some point we have to upgrade. But we don't want to upgrade until it's necessary. Also, we don't want to go into the area of accidental complexity, where the outside world is actually simple, right? If we have a single product vision, why do we need to build distributed applications? Why do we need to put all this complexity of uncoordinated releases and go through challenges of observability? It's not necessary, it's accidental complexity. So we try to navigate the path of least resistance. So what you can find yourself in your particular situation, try to identify where is your product on the horizontal axis. Like what is your world really demanding from you? Like, do you have a single customer who knows what they want? Do you have hundreds of different personas that work in different contexts and that come and go, and you really cannot predict what they will want? Right? Depending on that, you will know in which direction you need to steer. You might find yourself that you have a unified product vision, but for some reason, I don't know, your CTO or somebody decided that we definitely need microservices. So you might find yourself in the accidental complexity corner. So you can try to restructure your teams to start to simplify your solution, to work yourself backward. But it's hard, of course. So as I mentioned, it's easier to delay the progress on this chart rather than try to unwind it. But it's possible. And again, look at how your teams are structured, because how your teams are structured will ultimately define how your architecture is structured. Don't try to build services for teams. The teams will build services for themselves if you structure them in the right order. So I appreciate your feedback. You will find this QR code on the way out as well and on the walls. Please let me know if you have any comments. I'll publish the slides. They have some links to materials and articles I've mentioned during this talk. Also credits for the images I've used. And the game is not over. Now it's your turn. You can find me on Twitter. I'll be here for 2 days. You can approach me and discuss. Maybe everything I've talked about is crazy for you. So I'd like to hear that as well. And if you have any questions, we still have some time. Thank you. Questions? Yeah. Can you repeat, please?
You mentioned about extreme programming.
Yeah.
Can you elaborate a little more?
Yeah, so extreme programming is one of the oldest agile methodologies, publicized by Ken Beck, and in the book Extreme Programming Applied. Yes. So if you search for extreme programming has a number of practices that work well together. And how Ken Beck describes them is, we've identified the practices that worked well for us, and we've turned them to the maximum. That's why it's called extreme, right? They identified, for example, that refactoring makes the code better ultimately. So that's why they do it continuously. They've identified that when two people work together on the same machine, they make less bugs and solution becomes simpler. So they do pair programming all the time. They've identified that continuous integration actually is easier than integrating after months of disjoint development. So that's why they do it all the time. And I'd really like to stress this. To me, this is the obvious domain of organizational structure, right? This is like, if your organization doesn't apply those practices, then you really should. It's not a matter of oh, it will not work in our context. It will. It will if you try. And this is really the best practice in the industry, how to develop software on a single team scale. And basically on a multi-team scale, you still apply those practices, but you need more practices to coordinate multiple teams together. So if you've not heard about extreme programming, maybe you've heard about Scrum. So Scrum is basically extreme programming ripped off technical practices so that it can be applied outside of software engineering. More questions?
Do you have dev mesh in your standard Java? And do they have to be co-located?
Co-located? No. I cannot comment on Standard Chartered. I'm actually representing myself in a personal capacity here. But the example I mentioned, GitHub, is a company that worked from the beginning as a primarily distributed remote organization, so it doesn't have to be co-located. Also, open source communities demonstrate that this model can work when people work in different time zones at their own schedules. More questions? All right. Thank you very much.